So before I introduce them, everyone who has a bug for game development, give me a cheer. Alright, so our first speaker is Saban Kumar Suna and our second speaker is Debajit Ghosh. Both of them are senior software developers at Electronic Arts. They both have a working experience of almost 8 years and specialize in gameplay and interactivity. So please, can we have a huge round of applause for them?
Hey guys, am I audible? Sorry. Is it audible now? Okay. We'll just start by playing a video.
This is a story about athletes and zombies, about battlefields, battles on the pitch, and battles in the living room. It's a story about dragon slayers, dreamers, and icons. This is how we make games. Game development begins with an idea, a spark, a kernel of inspiration that takes shape in brainstorms and daydreams. Who, where, what, and how? Designers answer these questions. Game mechanics, characters, their stories, and their worlds are captured in design documents. These become the blueprints for every game. Concept artists visualize these ideas, making the abstract real. From sketching a character into existence to finding the right palette for a new level, concept art provides direction and guidance for every artist. 3D modelers give this art dimension. They sculpt everything you'll see and touch inside a game. Environment artists take these objects and create levels and shape worlds. An animator breathes life into this work through motion. How will a basketball player dunk? How does a movie star walk? How do our heroes smile or cry? An art director sees that this work comes together, ensuring every game has a cohesive vision. Sound and music are as important as a game's visuals. Sound designers build libraries of effects that can give our games a sense of realism and make them unique. Composers capture a theme or mood with the score. Actors give voice to our heroes. An audio director sees that these pieces come together, creating a rich soundtrack for the virtual experience our players will have. Games are, of course, more than moving and talking images. They're interactive. Through code, gameplay engineers build the systems that drive the game. They give players the power to play with the worlds we're creating. Server engineers make sure that things like leaderboards are up to date and accurate. Rendering engineers see that the fidelity of our games are top-notch. Whether implementing a new feature or fixing bugs, software engineers are problem solvers and architects. Design, art, audio, and engineering. These disciplines are brought together by a producer. They prioritize tasks, track progress, coordinate handoffs, and drive communication. Games can change over the course of their development. What did we learn from testing? Is it fun? Is this a quality experience? These questions have to be answered. With thousands of game makers around the world, these talented, creative individuals, through iteration and polish, all armed with player feedback, they strive to create the games that inspire the world to play. Games that let us play together, explore new worlds, win the Super Bowl, command armies, and pilot X-Wings. This is a story about
Hey guys. So hi, I'm Sapan. I've been working at EA for almost 9 years. This is a journey, big journey which I can see. Right now I'm leading TSM. I don't know if you guys followed The Sims Mobile. Give cheers if you. Okay. Good. So yeah, I've recently started to lead TSM. It's just 1 year for me, and I've been with EA for 9 years. I've been also doing code architectures for different projects which we have, and I also take part and lead in scheduling all the learning sessions for our studio. And my expertise actually on gameplay, physics, maths, profiling, optimization. optimizing, and I am also a part of interview panelist. We'll discuss at length on about each topic. So, brief history about our company. So, EA is a global leader in the digital interactive entertainment industry. I'm sure everyone must have heard about EA. A lot of games we make. Some games are The Sims, Apex Legends, Need for Speed, Battlefield, FIFA, NHL, UFC, and a lot more, right? Our game set contains United players playing on consoles, mobile devices, computers, over 300 million registered players globally. So we basically develop games for all the platforms. So I'll not waste much of the time. I just want to get technical and discuss more about technical items. I believe we have a Q&A session later after our session, so we can, if you have any questions, we are all available to discuss more. Yeah. So if you've seen the video, right? So there are a lot of people involved in game development, and it is not a single person's job. There are a dedicated team for individual parts, starting from design, art, there's QA, there's development, and there are a lot of other third-party teams who work with the actual development team to make it success, right? So how does it actually start? This is the basic summary of our development flow. Initially, this is for the fresh game. Ideation stage happens, either the designer or the producer or whoever generally in our company has an idea and wants to pitch about it, can come up with a concept and ideation. We do a small round of prototyping around that concept to see if it is valid, if it will be good to develop, go ahead and develop it. And if it is graded by the team, then we go ahead and then start preparing the design documentations. So every department usually has a lead, a tech lead, a art lead, a design lead. They generally are the first people who come across together and then discuss more and then formulate and design, fix a solid design for what we want to develop in the future. And then slowly each and every team gets involved. Our focus for today's talk will be mostly about development, as in the programming team, because we both are the software engineers side. Then the actual development happens. Obviously, the development is phased across timeline, which is decided for the project. There are obviously different milestones, which are decided on date wise, and both producer and really the project takes care of what has to be delivered per release basis or per goal basis, per phase basis. Once a phase of development happens, then it goes to a development, a deployment and a QA team. They do testing based on what we had decided to develop on and is it actually developed properly. There are a few UACs we call, as in the targets for the goal, which QA checks and says if it is clear or not, if it is graded. Then once all the phases complete and we are ready for release, we go to market. Now this is just a summary. There are a lot more different things which happen, a lot more to and fro happens. Fine. Obviously, games are like softwares, right? So there are a lot of technical elements there, and you can see here for programming, for analytics, for protocols, for cloud messaging, in memory databases. There are a lot more things involved. When we come up with a concept and we decide on what platform we want to use, at that point of time we also decide on what tech we want to use, and that completely depends on which team is going to work on it and what is the team's expertise or what is the end goal or how many platforms we have to target, you know. All these things are taken into consideration when we decide on which tech we have to use. Plus which, not only the client tech, but also the server side tech. Based on, is the game going to be a multiplayer game or a single player game, or is there going to be a leaderboard? All these things are taken into account while deciding a tech. So two major components, you could say two core components, development components of our game, client and server. Sometimes what happens if it is a very small game, there might not be a server component, but nowadays almost most of the games have server component because server has become a critical part. And obviously multiple clients can connect to a single server, and we'll discuss more about how it works. Right? So let's dig into client development. So client programming happens with multiple languages. This again, as I mentioned, depends on the project, depends on the team, depends on multiple things. Right now, if you see professional game development, I feel that most of the development happens with C++. But with a lot of game engines coming like Unity, right, which has a lot of support, it makes the work easier and gives you freedom to do more, which has C#. So that is Python. Python mostly I used for, it is not directly used in the game because it is slow, but it is used for a lot of our pipelines, such as like what happens to the assets. So there are, say for example, there are 3D artists who are working on some models or textures, right? And then it has to go to a game. So it does not directly go to the game because the game is optimized and uses some kind of pre-decided tech. So the art assets and all the textures are pre-cooked, pre-built, and are made ready for the development through external scripts, which are mostly Python. There are Lua, which helps us in doing quick prototyping and embedding in the code client. JS and TypeScript mostly for, say, dev tools for our development, which will not be a direct on-client development, but a support tool where it could be used by a PM or a producer or a QA to set up things in for the game while testing, right? There are not many languages used which are not listed here. This is a brief summary. Again, the clients, right? With game engines like Unity and Unreal coming in, we have a lot of exposure to different platforms. Or else it was actually earlier a lot more difficult because each platform has its own set of requirements, right? iOS has to be handled separately, Android has to be handled separately, Windows has to be handled separately, but Unity has made it easier. Same like Unity, we have our own proprietary software which we work with. So these are some of the list of platforms which games can be targeted into. So let's talk about frameworks, right? When I mentioned proprietary frameworks, we have some frameworks which have been developed by all EA employees. As and when they are working on the project, they keep on developing and making it better for the people who will be working on it next. Apart from that, we have our own Frostbite game engine. I'm not sure if you have read about this, but yeah, a lot of games are made, a lot of console games are made. Then obviously there's Unity, which has become very popular, and I feel it is the first choice for people who are just starting game development because it makes it so easy. There's Unreal, and there's Cocos. I'm not sure if you've heard about Cocos. It is basically a rendering framework which works quite well. There's this CryEngine as well. You might have heard from Crytek, right? Here are some of the screenshots of Frostbite engine. It is just like any game engine, but we have made sure that things run properly under hood for different components. This is for Unity. So why Unity or Unreal or Frostbite are famous? Because they they solve the difficult part, which is handling the game in the hardware, and gives you freedom, right, to focus on the development. For programmers, it has always been a challenge, to solve device-dependent items. But then with this, we can then not only focus on the device-dependent items, but also focus on the game-related items, as in what happens in the game, as in the gameplay, or the physics part of it, or the animation part of it, and dedicate our time there. So the development cycles have become a little shorter, but then as the quality of games increase, right, we have to invest the same amount of time. So yeah, here are some of the core concepts which we could discuss upon today. There are obviously a lot more. We can take it offline and discuss more. First is gameplay. So I've been specializing in working on gameplay for a long time. What is gameplay? anyone has any idea about what is the gameplay? No? Gameplay is actually a broad category. Basically, when anyone starts a game, right, what they do, they try to move a character in a 3D world or a 2D world. They do some interactions like controls, like it could be a keyboard, joystick, or whatever input you want to use. And there will be some level which the player has to go across. So all these things can be broadly categorized and it can be brought under gameplay. But there are again subtopics, right? We'll see if we have time, we'll discuss on them. Generally, if you see all type of mechanics in game, it could be your player movement, it could be your level movement, it could be your or if you see 3D games, there are a lot of logics where the climate changes during your gameplay. Even all those things are counted inside gameplay, obviously inside under the subtopic. How a gameplay is decided? That is basically designed and decided by a designer, whoever comes with the idea. So they make a prototype or a showable version of what has to happen, and that is taken into account during the development. And the whole team focuses. So they take a bigger task, break them into different parts of it. We call it sprints. We plan, so either a sprint could be 1 week or 2 weeks, and then we set a goal for us to achieve at the end of the week, and then we work towards it. And we keep referring to what the design people have already made for us, as in the prototype. Right? Okay, got my stuff here. Fine. It's not showing us. One minute, right? Yeah, fine. So that is what gameplay is. There are different logics, different intelligence, different simulations. And gameplay is such a category where all the different subtopics or different parts of the game are connected to, right? Say artificial intelligence or the audio part of it, or visual effects or animation. Everything actually is connected to gameplay, because gameplay is a core part of any game development process. And if you don't have gameplay is basically, you can consider it to be like a game, right? Fine. Okay. Next is rendering. Rendering, you can say it is mostly visual, right? So rendering is everything which is shown on the screen. Obviously, it has a lot more complexity under hood, and there's a prototyping set and the visual quality set, and so the whole team works towards that. There are a lot of so obviously this touches the underhood APIs of all the hardware devices, because it has to show something on the screen, right? And every device is different. They have their own set of APIs. It could be dependent on OpenGL, or OpenGL and DirectX actually are wrappers of the hardware rendering APIs. But then even OpenGL and DirectX has its own set of complexities, right? Which everyone will not be comfortable working on with, because every person who works on a game might not be a renderer engineer. They might be a gameplay engineer, so they might need a simpler API just to show a character or a box or whatever they want to show in the game. So there are a lot of wrappers written. With all the game engines and frameworks which are in place, it makes it very easy to show something, to change a color, to put a texture, to put a shader, and anything which comes into visual can be into rendering. Like you might have played NFS game. When you play the game, there are a lot of effects in the car, right? There's a blur, there's a color change, there's a shake in the camera when the accident happens. All these can actually be accounted into rendering. It is quite a complex topic, and a very few people are actually specializing in this, right? Because it needs a lot of knowledge about OpenGL, DirectX, plus Vulkan. Now that Apple has made sure that all the devices are Vulkan approved. I've just listed some of the keywords in these slides. We can discuss more about any of the keywords if you want to. Yeah, this was the last minute addition, artificial intelligence. I wanted to mention that obviously a lot of people might be interested in artificial intelligence. There are a lot of things actually happening with AI in terms of game development, because games, if you see, it is like a simulation, right? And then it could be either learning or it could be either normal project development. If you're interested in AI, you can simulate that using games. There are a lot of games like Battlefield, even mobile games, Sims and all, which uses different levels of UI. There could be a very simpler game which could use a very simple UI, like just a chasing algorithm where the enemy just goes behind, like Pac-Man if you have played. There is a level, the enemy knows how to traverse the level. That is the first knowledge the enemy gets. And then the enemy starts to chase, right? That is a fairly simpler AI if you compare with other games. Because a lot more 3D games have a lot difficult, complex AIs where the AI does all its calculation in a 3D world, right? So it has to traverse, it has to know where it can travel, or how it can travel, or what he can learn from the player. Some games do cheat and directly provide players position to the AI, so that obviously if we want to do a detailed level AI implementation simulation, you need a very high processing power, which is not available during game development, right? Because game has to run and render the whole frame in like say 60 seconds in an ideal scenario, which is not possible if you want to do dedicatedly perfectly simulated artificial intelligence. But then we do take some of the concepts from AI and then try to implement that. So these are some of the concepts which I've tried to put in the slide. There are a lot more. We have dedicated teams working on AI research, which then gets passed on to different teams to implement. Yeah. Cool. That is all for client development. So we can catch up later if you have more questions. I'll hand over to the Bashish.
Hey guys, can you hear me? So far we've been seeing one side of game development, the one you see on your devices, right? So have you ever wondered what goes on in the back end? So what happens before you shoot the first bullet, or what happens after you shoot that bullet? How the other person knows about it. So all of that is covered in server, right? So my name is Devashish. So I've been working 8 years, close to that at EA. So in these 8 years, I have explored quite some games. I have worked in the PVZ franchising. I have also worked on Sims and some other games as well. So we'll try to cover some of the basic topics today and see how it goes. So what is server engineering? So basically you have your servers and then you have your clients which runs the game, right? So we try to build an interface between them. So we want to make sure that when clients ask for some data from us, so we are able to give them the data. So we have to make sure that if they are asking for some opponents during matchmaking, so we are able to give them that. And you have to make sure that whatever data you have, right, we are storing the data, and that is available when you're playing across multiple devices. So all these things comes under game server engineering. And there are a lot more topics of that. So it'll come one by one. And so for to make this happen, so we have to build solutions which are scalable and which are very well distributed, so that the lag for you becomes less. So let's say you are trying to shoot a person, and if you're having very huge lag, so that experience will be quite bitter for you, right? So none of us wants that. None of us wants a laggy game, right? So we make sure that that doesn't happen, or we at least try to make sure that that is minimized. So one of the ways of doing that is making sure that whatever opponents you are getting, or whatever you are doing, like you are doing it in close geographical proximity. So that is one way of doing it. Anyway, moving forward. So we broadly classify the games that we have into two types according to server. So we have single player games. So in this type of games, the involvement of server is very less. So it's mostly limited to storing your data, storing your inventory, storing whatever progress you are making. So that let's say you have switched your device, you have changed your mobile phone, and you want to play the game on another device. So you don't want to start afresh, right? So you want your progress to be carried over from this phone to that phone. So we make sure that happens smoothly. So it might also happen that you don't like the game anymore, so you uninstall it. So what happens when you install it back? So do you get the data back or do you not? So then we can give you those options, whether you want to start afresh or you want to continue where you are. Right? Then there are saga games. So you have heard of Visual Kids, right? Or Candy Crush for that matter. So all of this comes under saga games. So these are all actually single player games. So we don't have any real-time communication with other players. So then comes the multiplayer games. So multiplayer games are where multiple people are playing the game at the same time. So you're shooting each other, you're killing each other. So what is happening in the back end? So basically all your game logic and everything is running on a headless server somewhere, and that information is just getting relayed to you. And once it is relayed, so that is where client engineering takes over. So it makes sure to show you those animations. It makes sure to show you those effects, how a player is dying, all those animations, everything after that client engineering takes over. So that part of the communication server is responsible. So as you can see, there are different types of multiplayer games. So we have Battle Royale. I'm sure you must have heard of Apex Legends. It falls under that. Then you have MOBA games. Then you have MMO, massively multiplayer online games. So all these things come under multiplayer. Moving forward. So I'll be briefly discussing about some of the server components that a typical player encounters, and so all of this is happening in the back end. So you might not be aware of these things, but just think of it. So a user is playing a game, and he might be playing it for quite some time. So let's say for 3 hours, for example. So all of these things a user will be interacting in that time span, and it is not necessarily that all of these components will be touched in every call, but every call that you're making to the server, but maybe somewhere in the 3 hours it will be covered. So the first part is auth and security. So first of all, we need to establish that you are the person you are trying to be, right? So we don't want someone else to be logging into your account and playing the game. So that's why we have auth and security. So that is the first thing that we do when a player logs in. Then we have player progress and inventory management. So this keeps track of your progress. So how far you have progressed in the game, or what all you are holding in your inventory. We try to retrieve the data and give it back, so that the game client can show them to you, and you can do stuff with that. So next comes config and asset delivery. So oftentimes it happens that a game is launched with some configurations. So when I say configurations, so let's say you're playing with a character, right? So that character will have attributes. So let's say health is one of them, right? So all of these are highly configurable. So we can change any of them on the fly without doing another release. Right? So all of this comes under config and asset management. So similarly, you might notice a change of art style, maybe related to some events or some festivals. So all of this is taken care of at the next level. So we just figure out what all you need to download, and then we give you those things. So client automatically downloads it, and then you see the changes in the game. Next comes leaderboards. So maybe you've been playing a battle, maybe you're competing against other players, So you see where you stack up against other players. So that is where leaderboards come into picture. So we make sure to maintain the leaderboards and update them at regular intervals so that you can see where you stand. Then finally, you have matchmaking. So the experience that you have is vastly decided by the type of opponents that you're given, right? Even it is a competitive game. So you don't want to be matched against someone who is far superior in tactics only or far inferior. So all these things are taken care of by matchmaking. So we always want to make sure that you are matched up against people who are at your same level. Right? Then you have different live service levers. So these are things that we try from our side to make sure to experiment something new. Maybe we want to introduce some new features, and we want to just test how the audience is receiving that. So all of these things come under there. And finally, other miscellaneous things that you can think of. So for example, you might have some cheat detection engine, right, which is running in the backend. So we make sure that any person who is playing the game, right, the person is not cheating, or if he is cheating, what do we do with them? So all these things are taken care of in miscellaneous. So each of these components, you interact with one or more of them in every call. And in an user session, which can be a varied length depending on the type of the game. So you will be interacting with all of them at some point of time. And there are other components as well. These are just a few. And coming to the most important part of server engineering is all of that is fine, but what if the performance is not good? What if the game is lagging? So how do we make sure that what the player is experiencing is good? So we have various ways of doing that. So even before a game is pushed in the market or a new feature is released, right? So we do our own internal testing. So we make sure that the player would not experience something which is very bad, right? So for this we do load testing and other testings as well. So we do a projection based on the data that we have from our project managers. So we just estimate how many players will be playing this game, and after that we go and test whether the infrastructure that we have, right, whether it will be able to handle that load. Or what if it is 5 times that load? So let's say you only plan for 100 players, but you see that on launch day 500 players turn out. So will your infrastructure be able to handle that load? So all of this comes under scaling and performance tuning. And we do multiple passes on this, since this is the most important thing, to make sure we are optimized in every possible way. Right? Because on server it is the same for all players. It doesn't depend on your device, so it only depends on what is the optimization level at the server. Cool. Moving forward. So as Sapan was mentioning, right? So gameplay, with gameplay there are a lot of things, and we make use of a variety of languages. So similarly for server, so we make use of a lot of tools. So as you can see, typical choice of languages is Java, PHP, Go, Python. So each of these can be used again like in a variety of ways. So you can write your game servers in Java, but you might have your tools. Again, tools are some secondary support things that exist to make the game more configurable. So what happens if some player is complaining that I have lost my inventory? So how do you check what the person has and whether he has lost that inventory? So all these kind of tools also we need to build. And you see all these languages, so all of this makes helps us building that. Then you have frameworks that we use, so it can be very varied. So for Java, we can use frameworks like Spring. Then you have .NET frameworks, which has if you have a C++ server or a C# server. And at present, all of our servers are hosted in the cloud. So either we use Google or AWS. Again, depending on the game team, that might change. But all of our servers are hosted in the cloud, and we make sure that the scaling up is done automatically. Like I was mentioning, so let's say there is a spike in the number of users, and you see a huge influx of players suddenly. So this is where that comes, that advantage comes into picture. So we have virtually unlimited hardware when we move to cloud. Yeah. And then we have the DevOps, which is again very important. So they make sure that the infrastructure is stable. And if there is some error, that we are instantly notified. And once we have that notification that something is going on, we try to dig in deeper and find out what exactly is going on. So we have logs to see what exactly is the problem. Maybe the problem isn't in the logs, maybe it is something else. So all of these things come under your DevOps. And finally, even before any of this takes place, right? So we do thorough testing of our code, and so you can see various types of testings that we do, just to make sure that whatever exists doesn't break, and finally it is able to take any amount of load. Cool. So yeah, I'm going to now discuss about what excites me to be part of EA. So I have joined EA fresh out of college. It was like a dream come true for me. And every day that I go to work, I just do what I love, right? It's game development at the end of the day. So you get to play a lot of games while you are at your work. Even you are expected to play games to better understand your players, better understand their problems, right? And what you do has a direct impact on the players that you are working for, like that you are developing the game for. And let's say you're playing a game and you feel that, hey, this is a feature which would greatly benefit the players. So you can even go ahead and suggest that. So there is no constraint. Like you can even go to any person and say that, hey, I have this bright idea. Why don't you put that in the game, right? And moreover, like the type of challenges that we solve every day, that is also very unique. So let's say talk about this cheating detection. So cheating is something which is very much unique to gaming, and even game specific, right? So your cheating in FIFA might be very different from the way you cheat in other games. So it's very challenging every day to deal with such scenarios and to be able to solve them. Cool. I think with that, this comes to an end.
The Empire's time has come.
I got a good feeling.
We have a common enemy
I got a good feeling.
and a common cause.
I got a good feeling.
We're in.
I got a good feeling. Yeah, I'm talking about it coming back down. Feeling in my bones, gotta shake it out. I'm going harder than before, let me push out. I run around the whole world, chasing that thrill from the bottom to the top, and knock it out. I'm about to go, ready on the go, steady shining brighter than I ever did before. When I'm up in the clouds, and I ain't coming down.
Everything we've done has led to this.
Come on, move to the sound. Keep it going, and burn it up. Yes, that's the move.
Every driver here is out to crush you.
Just in name of these parts.
Maybe we can skip the mic. They can talk loud.
Yeah. Yeah, sure.
So basically, my question was, we use AI-based rendering as well, like to generate 3D objects in certain ways. There are methods right now which help in rendering just by using network, like neural network, to actually stylize some 3D objects. Do you use that kind of methods as well in your games, or is that not yet?
So this is a quite advanced topic. First of all, what happens is AI-wise rendering, and I feel, okay, did you guys hear the question by the way? Okay, she was asking about what about AI-wise rendering, right? And are you referring to the new streaming service which like Google has started?
No, I mean something that has a basic model, but you stylize it based on some text prompts or image prompts.
Okay.
How do I decide the parameter? Is that your question? So again, so there will be game designers who will be coming up with these numbers. So like I mentioned, so one of them could be your kill death ratio, right? So like this, there might be enough parameters, and depending on the game team, depending on what the game designer is thinking, how the matchmaking should be made. So I'll give you an example. So let's say you're not playing a shooter. Let's say you're playing NFS, right? So how do you think the matchmaking should be made? So you will perhaps check the lap timings, right? So how fast that guy is going. You might be checking how many times he's come in the top 3. So all these are stats that we track, and depending on the game, we choose the parameters. Cool.
I guess, yeah, you guys both lots of multiplayer games, right? So, for example, if I take like something like Call of Duty, you have like 8v8 lobbies, which is not very easy and hard to handle. But when it comes to Battlefield or Apex and something like that, where you have like over 100 players, a lot of players, so what are the technical challenges that arise to the huge number of players?
So this question is like, let's say when you have very less number of players versus when you have very huge number of players, how does it change the way you handle the server load, right? Yeah. So for us, it doesn't matter much about how many players are connected. Obviously, see, the input will keep on coming, right? And a lot of it depends on the network that you're running on. So there will be stuff like packet loss and all that. But it again depends on the game team. So the solutions that we have are built intelligently. So sometimes it will just assume that you will be going there, right? And so it will continue there. And so we only, so think of this. So you have a game world, and the entire game world information is available with you, right? And let's say you're just moving a bit to your right. So let's say 1 square to your right. So what will happen is you will only get the delta. So your client will know that, hey, I've only moved one unit to my right. Similarly, all other clients will only know that. So as this grows, like if the number of players are too high, so we try to minimize this. So there might be other clever hacks that we do like this. So again, like it completely depends on the game team how they come up with these approaches. And for sure, network is one problem. And if there are many players, then the game becomes more complex. So maybe the server on which the game is actually running on the cloud. So that also needs to be improved. Right? So you might be assigning more threads to it so that it runs very smoothly, and like all of the deltas are given out very instantly. Good.
Follow-up question.
Yeah, sure.
So I assume when it comes to these huge games, servers are much more expensive to keep running. So how exactly do you, from like a business standpoint, how exactly do you decide to keep this game running even though it has a huge number of players versus this game is a single player game which does very big server space but like sells. So how exactly do you plan to keep a game running even on.
So his question is like, so as the number of players keep on increasing, or depending on the game type, you might have, the requirement of running a lot number of servers, and the game might not be having that much revenue, right? That is the question you asked. So again, like there are specific teams to take calls on this. So from our technical team, we estimate the cost that will be incurring, and then we pass on that information, and there are project managers, other analysts who take a call on whether a game should keep running or not.
Just to add on, what we also do is we keep a search of better tech. So while a game is running, we do a cost analysis. We also see if there is any other solution which will give us benefit. We have done this like in BW and all, where we moved our tech just because we knew that we could do better with less cost.
Another thing is that in server engineering, so another very key aspect is we always keep on optimizing. So let's say we, for one of our games, right, we moved out of one proprietary database that we are using to something in the cloud. So that saves us money there. So as tech is improving, there are constant, optimizations that we can do. So all of this adds up. Good.
In many games there are like bots, cheating bots, which the game is like get a headshot and will complete. They does by itself. So as to prevent it, what is the basic procedure? If what the player who is playing against, he just feels like he's getting a headshot every single time. It might be a pro player or a cheater. How to differentiate from the person?
Okay, so if I understand your question, you're asking how to differentiate a
Between a cheater and a pro player.
cheater and a pro player. It is quite difficult for us. So it is not straightforward, but what we do is, when we develop a game, we know, right? We pre-decide and we know what flow a normal player takes, or what could naturally be possible. Those parameters are taken into account. Like a lot of times, obviously, bot is very intelligent. It will be very difficult task to do, but then this is not a one-time call which we take, right? We observe the player for quite a long time, and then we see what all he is doing. A single player cannot just jump from one state to a very high level at a stretch, and obviously cannot earn a very high delta when we have not designed in that way, right? So there are a lot of parameters that are taken into account, and an accumulation of all this calculation happens. Now different games handle differently. Some games have something like a special score based on which we decide if he's a cheater or a actual player. And it depends on team to team, game to game, and how the game is designed as well. It's a very tough question to answer.
Yeah, sure. So I think there are patterns which we observe. So most of it presently is done through community reporting, although we run our own internal tools to identify cheaters. So let's say there is a player whom the community is reporting. So we definitely look into that person and see if anything on this one. So there are specific patterns which we can identify, looking at other players' data as well. So that definitely helps. But yeah, that is a very tough thing to solve.
In your day-to-day work, how much of maths and hard physics are you required to use?
Yeah. So your question is how much of maths and physics do you actually require? See, that again depends on the game. It is very straightforward if you think, right? First, what we have to do is decide on what game you want to make. What logics or mechanics your game has to be using as per the designer's idea or whatever plan you have made. Obviously, if it is a racing game like NFS, there are a lot of things which are related to motion, like you've studied Newton's motions and your basic physics and maths, whatever implies to make an object move. All those things are used. Not to the extent where we do research or simulations, but below that, because our basic criteria is that the game has to be playable. We obviously use dot product, cross product, and things like that, which is very common nowadays for every game. But again, if it is a physics-based game, or if it is very simulation kind game like NFS, or you can also say there are a lot more racing games which are much more complex than NFS. NFS's criteria is to give you fun, but not the very driving experience which you would want to feel. So it depends on the game, on how heavy or complex math physics you want to integrate in them. Ultimate goal is for us is obviously to have fun. But you feel free, if you're doing a prototype or you want to do some testing around your physics and maths, if you're interested, you could always do that.
How much of games both resources and components are used, for physics engine, for example, for Apex Legends? If you were to make some other FPS game, would you reuse the entire physics engine, or would you take part? What would you do? How much changes? What changes?
So that depends on which team is actually developing the game. Often what happens is if it is a single studio who are developing the game in some frameworks like Frostbite, say for example, then that would internally already have the set of physics which are required for a game of that kind, right? Which can easily be used. But then if there is a team who is not aware of Frostbite, then the call will be on how complex do you actually want to implement them. Then we maybe tie a partner up and then develop. If it is not a very heavily physics driven game, then there are a lot of instances which I have seen where the studio itself develops them from scratch.
Yeah, somebody has.
Yeah. Sorry?
So for me, I would say I work in the PVC franchising, so I'm very proud of that because we have certain challenges there that we have not seen before. So for me, it was a game that I was it's fun. What about you?
So I've been part of multiple projects. What I love the most is doing prototypes. Apart from actually like doing a proper game development, because prototypes for me it has been such that I can quickly test my idea or a concept. And if you see a lot of games comes nowadays, right? So I always look out for game mechanics because I'm very interested in gameplay programming. And then what I do is in my free time or during office prototyping, whatever we decide, I try to simulate the whole game mechanics which I have seen or referred to or read about. So that is the reason. But apart from that, NFS has always been my favorite game. I've been part of, not for very long, but very short span. Yeah, right now I'm dev lead for the Sims Mobile. And it is a quite interesting project where you have a whole 3D world, you have Sims, you can do a lot of things with it. So yeah, if you follow that game, then yeah.
So the designers who create all the characters and who are responsible for making environments and background stuff. So does both the technical stuff and the design stuff, they go side by side, or you need first the visual parts and then you work on it?
So you're asking whether designers and the technical things go side by side during development. So actually what happens is, see, we all, when we start development, we need a vision, right? We need a target. Because we want to know beforehand how it should look. So for that, what happens is the art team first gets on, and they are the people who start making assets. Assets could be 2D assets, 3D assets, 3D models, whatever visual item it could be, right? And then they go hand in hand with the art director to reach to the visual state which we want to deliver. But obviously that is not a single time goal, right? It's a long process. So obviously the tech is along with the art people. First the art guys come up with some dummy models or objects or some bare minimum items which can be taken into engineering and implemented upon, right? So that implementation happens parallelly and the art development happens parallelly. And then whenever in regular cycles art is developed or it is brought to a better state, that is integrated again. So that is how both the development departments go hand in hand. And always there is a designer, there's a producer, there's a QA to cross-check on every sprint or every 2 weeks on whether we are moving in the right direction or not.
Guys, are there any more questions?
Yeah. This is also going to be another weird question. Okay. It's just a personal observation of mine that multiplayer sandbox games are quite rare. In your personal experience, have you worked on sandboxing in games, and what is your opinion on it, and how any challenges you have faced? When's the next Minecraft now?
What did you mean by sandboxing?
So what I mean by sandboxing is that non-linear gameplay or uncontrolled game flow.
Much like open world kind of things where you could do things. That we are not aware of. As a development team, we don't have that reach right up now. At this point of time, there might be other teams working on it. We're not sure of.
Audible? Yeah, so lot of you have questions that our team, both of these experts are from technology background, and the first video that you've seen definitely gives you an idea that there's much more to developing these games apart from what these experts bring in, that is technology. And what we observe is a lot of your questions also come from those domains where our experts who are here are definitely technically very equipped, but other people might be give you a better answers to your question. So I'll coordinate with Harsh and your Felicity team. Do drop in these questions for us. What we can do is get back with responses. Might be share few videos that are public out there that you can watch so that your answers get much more holistic answers. So we can do that. Do drop in questions. I'll pick them offline from the team and get back to you with responses that will better make meaning than what our experts shared today. Cool?
Thank you, guys.
So guys, I hope you had a wonderful experience attending this workshop. I also want to thank our speakers and Electronic Arts for conducting this workshop. Yeah.
So I have my team here from the talent acquisition. Both of them again technically rich here. If you want to have one-on-one chats, we are here. Feel free to come in, ask more questions. Might be an opportunity to network for both of us. So yeah, we are here around for a few minutes. We can catch up as well. Okay.
we just around here in the campus. You can come talk to us. Yeah. You can announce wishes and yeah. Thank you guys. I hope you had fun.
If you have any more questions, please go down to the conference hall downstairs. If you have any more questions, just like ma'am had asked, please go to the conference hall.
Conference hall opposite to the lift. Yeah.